What is acceleration, and how does it relate to speed and velocity? This is the question that students will explore in Investigation 4A, Acceleration on a Ramp. In Investigation 4A, students will use a smart cart to explore the relationship between speed, velocity, and acceleration. A cart with only gravity acting on it accelerates at the same rate, whether going up or down a ramp. Students will measure velocity and acceleration using the smart cart's built-in sensors, and by the end of the lab, they should be able to explain why the acceleration is the same going both ways. For this investigation, each student group will need a smart cart and a track with feet, an end stop, and 2 textbooks. For the first part of our investigation, we want a low angle for our ramp, so one end of the track is propped on one textbook, and the end stop is attached at the bottom to catch the smart cart. Each group will open the experiment file, 4A, Acceleration on a Ramp, in SPARKvue, and then turn on the smart cart and connect it using Bluetooth. At this point, groups are ready to begin recording data. In Part 1, students will roll a smart cart down a track while collecting data on its velocity and acceleration. Hold the smart cart at the top of the ramp with the Velcro facing up the ramp. Begin collecting data, and then release the smart cart. Stop collecting data just after the cart reaches the bottom of the track. Students can answer questions A through C in the student worksheet using their velocity graph. In question A, to determine the acceleration from the slope of the velocity graph, we're going to select a point on the graph and use the slope tool to find the slope at that point. So at 2.2 seconds, we have a slope of 0.384. Let's check to see how that compares to the acceleration. Look at the acceleration using the coordinates tool, and we see that they're very close to each other, approximately 0.38 seconds. For question B, the time elapsed can be read from the graph. If we look at the time axis, we see that it starts at about 0.75, and if we move this out of the way, we can see that it ends at about 2.8, so we can find the difference in time. For question C, the final velocity can be found using the acceleration from question A and the time from question B. As is described in the teacher guide, you can find the final velocity using the values. Students can use the same process to release the smart cart on a steeper track using a second textbook and rolling the cart down to answer questions D and E. In Part 2, we want a low angle for our ramp. This time, students will collect data on the velocity and acceleration while they roll the smart cart up the track and back down again. Make sure that the Velcro is facing up the ramp and begin with the smart cart at the bottom of the ramp. In SPARKvue, we will hide the data from our previous experiments. Begin collecting data, then give the smart cart a push so that it rolls up and down, and then stop collecting the data just after the cart reaches the bottom of the track. Compare the velocity and acceleration graphs for the cart rolling up and back down the ramp, and use them to answer questions A through C. In comparing the velocity graphs with the motion of the smart cart, your students will think about where the velocity is negative, 0, and positive. Since the acceleration describes how the velocity changes with time, it is the slope of the velocity graph. For question D, another way to find the slope is to use the linear fit tool. I'm going to select a region of the graph and then fit it. And I find that the slope of this region is 0.4, which is very close to the acceleration, or matches the acceleration through the same region. So the slope of the velocity time graph is the acceleration. For question E, since the ramp is at the same angle as it was in part 1, the acceleration due to gravity should have the same sign and magnitude.